Okay, so let's dive into a system that completely changed how we talk about color. For centuries, artists and scientists really struggled to define it in any kind of consistent way. But one man, an artist himself, came up with a logical language for color that bridges that gap between art and science. And believe it or not, it's still incredibly relevant today. You've been there, right? You're trying to describe a very specific color, but the words just aren't working. Is it sapphire, navy, maybe deep blue? The problem is, all those names are subjective. My navy could be totally different from your navy. And this is exactly the kind of chaos that artists were dealing with for a long, long time. And this very problem drove an artist and professor named Albert H. Munsell absolutely nuts. We're talking over a century ago. He was just so frustrated with all the ambiguous, poetic language people used for color, and he was convinced there had to be a more rational, consistent way to do it. His solution was, for the time, pretty radical. Instead of just relying on all these misleading names, he proposed a system to actually measure color based on three distinct qualities that our eyes perceive. It was this huge shift from just naming colors to actually defining them. Okay, so first up is hue. This is the most basic thing. It's what we all think of as the color itself, red, yellow, green, blue, purple. Munsell organized these into a logical circle with 5 principal colors and then 5 steps in between each one. Next up is value. And this one's easy. It just tells us how light or dark a color is. It's a vertical scale that runs from a perfect black at 0 all the way up to a pure white at 10. And what's really crucial here is that this measurement has nothing to do with the hue or intensity. And the final piece of the puzzle is chroma. This is all about the color's purity or its intensity. Is it a dull, grayish color, or is it a brilliant, punchy, vivid color? It's the difference between, say, a faded old brick and a bright red fire engine. That's chroma. In this diagram here, this is where it all comes together. It shows how Munsell combined those 3 attributes, hue, value, and chroma, into one logical 3D model. You can see hue circles around the center, value runs up and down that central pole, and chroma radiates out from the middle. Every single color we can possibly see has its own unique address, its own HVC coordinates in this space. So let's see how these dimensions build into Munsell's most famous idea, the color tree, because this is where his system really just broke away from everything that had come before it. See, earlier color systems, they all tried to cram colors into these neat, perfect geometric shapes like spheres or cones, but Munsell, because he actually did rigorous testing with real people, he realized this was a massive mistake. It just didn't match what our eyes actually see. And this right here really shows the contrast. On the left, you've got that idealized, perfectly symmetrical sphere. On the right, that's from Munsell's work. It shows the actual shape of human color perception. And yeah, it looks all irregular and lumpy, doesn't it? Well, that's not a mistake. It's a map of reality. So, and this is the key, that irregularity is actually the system's greatest strength. It accurately shows that a really vibrant yellow is naturally much, much lighter in value than a vibrant blue. A perfect sphere would force them to be equally light, which is just false to our eyes. Munsell's system is built on how we see, not on some abstract math. The whole color tree metaphor makes this super intuitive. Just think of it this way. The central trunk is the value scale, from dark roots to light treetops. The main branches circling that trunk, those are the different hues. And the length of each branch, that's its chroma, how far out that color gets from a neutral gray. Okay, this is all fascinating theory, but how can you, as an artist, actually use this in your drawing, your painting, or even your digital work? Well, this is where the Munsell system becomes a seriously powerful and practical tool. So how do you apply it? Well, for starters, try arranging your paint palette according to the Munsell hue circle. It makes mixing colors so much more predictable. It also helps you find true complementary colors, the ones directly opposite on the wheel that will mix down to a perfect neutral gray. No more mud. And you can even use it to take precise color notes out in the field, capturing a scene's colors with just a pencil. You do this using something called Munsell notation. It's a simple little code. Hue, then value over chroma. So YR3/4 isn't just some code, it's a precise recipe. It tells you it's a yellow-red, that it's dark, a value of 3, and it's not very intense, a chroma of 4. In other words, it's a very specific shade of brown. No more guesswork. Now, for you digital artists, this probably sounds pretty familiar. The HSB and HSV sliders you use in programs like Photoshop are direct descendants of Munsell's thinking. The huge difference, though, is that Munsell is based on human perception, while those digital models are based on pure math for computer screens. If you understand Munsell, it gives you an amazing mental framework to make way more intentional choices with those digital tools. Munsell's system was just so clear and so effective that its influence spread way, way beyond the art world. It's become a universal language for color in dozens of other fields. I mean, we're talking about geologists classifying soil, food scientists making sure every single French fry is the perfect golden brown, archaeologists documenting artifacts, forensics describing evidence. It even defines the safety colors on electrical wires. It's this hidden system that organizes the color of our entire world. So in the end, Albert Munsell really gave us a new way to see. He taught us that color isn't just some abstract feeling or a poetic name. It's a measurable, describable, and understandable experience. So that leaves a final question for you. How might this idea of measuring what you see change your own perception of the world?